Welcome back to another video. In this episode, we are going to look at how we can handle these three systems of equation, but we have two unknown variables. So we have to apply what we call the least squares method so that we can be able to minimize the errors in this particular problem. Okay, so here we have to apply this particular equation, ax equals b, right? So from here, we have to rewrite these three systems of equation in this form, where our a here is the coefficient of the variables, right? So is the coefficient of the variables. So the first coefficient here is 1. The 1 here is -1. This is +1. This is +1. This is +1, and this is +2, right? So because we have three systems of equation with two unknowns, we are going to have a 3 by 2 matrix, right? 1, 2, 3, and then 1, 2, right? So this is a 3 by 2 matrix. Okay, so we have our A. Let's look for our B. So our B is the constant aspect, right? So we have our B to be 1, 1, and 3, right? So this is our B, and our X will be the unknowns, the X1, X2, right? So we have all this information right here. So what are we going to do next? We have to um, look for A transpose times A, right? So we have to find the transpose of A. Okay, so the transpose of A, right? From here, when you want to transpose this 3 by 2 matrix, you're going to have this 10 down, this 10 down, this 10 down, right? So you're going to have 1, 1, -1, 1, 1, 1, 2. So that is the transpose to this particular 3 by 2 matrix. So when you transpose the matrix A, you're now going to have 1, 2 rows, 1, 2, 3 columns. So we have 2 by 3 matrix. So after the transpose from the matrix A, we have a 2 by 3 matrix, right? So now our A transpose times A, right, multiplied by the unknowns should be equal to A transpose times the constant aspect, right? So this equation, we are going to utilize it very, very well, right, to be able to find the unknowns. Okay, so here we have the transpose. We have to multiply the transpose by the matrix A, right? So we're going to have A transpose A, right, is going to be 1, 1, 1, -1, 1, 2, multiplied by 3 by 2, right? So we're going to have multiplied by 3 by 2. So 1, 1, 1, -1, 1, 2, right? So this is what we have now. So we have to perform the operation on this. Then we have our A transpose times A. So we perform this operation, this row, first row times first column, right? So first row times first column. So we're going to have 1 times 1, and that is 1, plus 1 times 1, 1 times 1, and that is 1, right? Plus, then we come to second row times, right? We are done with the first row, taking the first column. The first row again will take the second column. So we have 1 times -1, that is -1. 1 times 1, that is +1. 1 times 2, that is +2, right? So we take the second row that also distribute to the first column. So 1 times -1, that is -1. 1 times 1, and that is +1. 2 times 1, and that is +2, right? Then we take the second row again, distribute it to the second column. So -1 times -1, that is +1, plus +1 times +1, that is +1. Then plus 2 times 2, that is going to be 4, right? So basically, we're going to have 1 plus 1 plus 1, that's 3. -1 plus 1, 0, plus 2, 2. Then -1 plus 1, 0, plus 2, that is 2. And then we have 1 plus 1 plus 4, and that is 6. So when we multiplied 2 by 3 and then 3 by 2, we have 2 by 2 matrix, right? So we have 2 by 2 matrix. So the A transpose times A, we are having this result, right? So this is the result of A transpose times A. Now, we have to look for we have the A transpose now, right? We have A transpose. So we have to go ahead and apply our equation, right? So we know that A transpose times A times our unknowns is equal to A transpose times our B, right? So the next thing to do is to find the A transpose times the constant. Okay, so here, here we know our constant here, 1, 1, 3, right? So we multiply this constant by the A transpose of which we have here, right? So A transpose times the constant, this is equal to 1, 1, 1, neg 1, 1, 2, right? Then we take the constant, which is the B, right? So this is the B, multiply it. So we have 1, 1, 3, right? So now we are going to multiply 2 by 3 times a column matrix. So here, we are going to have first row maps to all the elements in the column matrix, right? So this times this, we have 1, plus this times this, we have 1, plus this times this, we have 3, right? Then we take this times this, we have -1, this times this, we have +1, this times this, we have +6, right? So this also yields 1 plus 1, 2 plus 3, and that is 5. That is 5. -1 plus 1, 0 plus 6, and that is 6. So we have our A transpose times B as this here, So now what we are interested in is our unknown variable, which is the x. Okay, so how do we do this? We have A transpose times A times your unknown is equal to A transpose times your B. We have this, you have this. How do you find this, right? Then before you can find this, it means you have to find the inverse of A transpose times A, right? So we need A transpose times A, its inverse. So what do we do? We have A transpose times A here. So we need the inverse of this matrix. Okay, so the inverse of that is going to be 1 over the depth of A transpose times A times the eighth adjoint at A transpose A, right? So we need the determinant of this and then the adjoint of this to find the inverse of that. Very, very simple. The least square method is so interesting. All right. So here, so here, so here, our determinant from here, our determinant from here, our determinant from here is going to be 6 times 3, that is 18, minus 2 times 2, and that is 4, right? So that is basically 18 minus 4, and that is 12, right? So we have 12 right here as our determinant, right? So we are going to compute the adjoint, right? So the adjoint of A transpose A is going to be, you negate, you change the position of what? The main diagonal, then you negate the off diagonal. That becomes your adjoint of a 2 by 2 matrix. So here, our adjoint will be changing the position of the main diagonal. This here is going to be 6, 3, then we negate the off diagonal. So we're going to have minus 2, minus 2, right? So this is the adjoint and this is the determinant. So what do we do next? So once we have the determinant and we have the adjoint, we can go ahead and find the inverse of A transpose A. So A transpose A, its inverse will be equal to 1 over the determinant is 12. So we have 12 right here. Sorry, 18 minus 4 is 14, 14, 14. Sorry. So 14, right? So 1 over 14, then we have 6 neg 2 neg 2, right? Then we have 3 right here. So here we expand this. When you expand this, you're going to have 6 over 14, then minus 2 over 14, then we have minus 2 over 14, we have 3 over 14, right? So this basically, when you try to simplify the element in the matrix, you're basically going to have 6 goes to 6, 2 goes to 6 3 times. So we have 3 over 2 go into 14 7 times, right? 2 goes to itself 1, goes to 14 7 times, right? Same applies here. Then we have 3 over 14, right? So this is the transpose, the inverse of A transpose times the matrix A. So this is the inverse. Okay. So once we have the inverse, we can go ahead and find the unknown variables. So here, here we know our A transpose B to be 5, 6, right? So here our A transpose A times the unknown X is equal to A transpose times B, right? So being able to find this, being able to find the inverse of this, then we can say that our unknown, which is X, is equal to A transpose A inverse of that. When you want the if you want the X, you divide both sides by A transpose times A. So when you reciprocate, it becomes the inverse, and that is what we have obtained over here, times A transpose B, right? So here our unknowns, which is the x1, x2, is equal to A transpose times this. So you have 3 on 7, neg 1 on 7, neg 1 on 7, and 3 on 14. So this times A transpose times B, and that is 5 on 5 and 6, right? So we multiply this 2 by 2 matrix with this column matrix, and we have to get a column matrix. So from here, from here, we're going to have our X, which is equal to x1, x2, right? Which is equal to x1, x2 will be equal to this rule takes the whole column, right? So we're going to have 3 over 7 times 5. So 3 over 7 times 5 plus 6 into minus 1 over 7. Then we come down here, 5 into minus 1 over 7 plus 6 into 3 over 14, right? So when you compute this very well, you're going to have 15 over 7 minus 6 over 7. And also the down, you're going to have minus 5 over 7 plus 18 over 14, right? So when you simplify this very well, the first rule, when you simplify the first rule very well, you're basically going to have 9 on 7, 9 on 7, and also minus 5 on 7 plus 18 on 14 is 4 on 7 as well. So we have 4 on 7. So this becomes our unknowns for x1 and x2. So we have our x1, x2, our x1, x2 to be equal to 9 on 7 and 4 on 7. So these are the possible solutions that we can obtain for this particular three systems of equations. So basically, let me write it here. So we have our x1 equals 9 on 7 and our x2 equals 4 on 7. So these are the possible solutions that we can obtain for x1 and x2. That is the best solution that can minimize the errors in these three systems of equations with two unknown variables. ladies and gentlemen, this is the process that we go through to find the least square solution for three systems of equation when we have two unknown variables. First, what you have to get when you have this kind of question is that you have to quote your formula, your equation, where we have the ax equals b, right? So you identify your a, you identify your x, and you identify your b, where your a is the coefficient of the variables, right? The a is the coefficient of the unknown variables, and the x are the unknown variables, x1 and x2, right? And the b will be the constant aspect where you have 1, 2, 1, 1, and 3. Okay, so once you have that information, then you come and say that A transpose times A times your unknown should be equal to A transpose times your constant, right? So you find this, then to find this, you have to, divide both sides by A transpose times A, divide here by A transpose times A, right? And you know that this will go off and you have X equals A, you want to reciprocate it. So when you take it up, you're going to have A transpose A, then that becomes inverse of that. So you have times A transpose B. So before you can go ahead and find your X, you have to know the A transpose times A, the inverse of that, its inverse, okay, times A transpose and times the B. Okay, so once you have this information, the rest is your computations. Thank you very much, ladies and gentlemen. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'll give you more updates. Bye bye.